In this video, we're going over the concepts of Chapter 3, which is titled Matter and Energy. In Section 3.1, we are going to learn what is the definition of matter, and we're going to learn how to classify it. By definition, matter is anything that has mass and occupies space. We have two images in the following slide. On the left side, we have an image that is illustrating different substances that are considered matter. As you can see, there's a wide variation of all the things present here, including the person, the spider, the sandwich, the computer, the water, the fish. There are many examples of matter. And the reason why all of these substances are considered matter is because they have mass and they take up space. In the world that we live in, not everything is considered matter, because if something doesn't meet the parameters of occupies space and has mass, then it's not considered matter. So on the right side, we have an image of examples of things that are not considered matter. They include a rainbow, a reflection, memory. When it comes to matter, it can be classified in one of these two groups that are considered pure substances or mixtures. In these two families of how we classify matter, we can see that there are also subgroups. We are first going to explore the left side where we have the categories of, or the category of pure substance, and then we're going to proceed to talk about mixtures. When it comes to pure substances, let's understand that matter can be classified further into elements and compounds. An element is a substance that is composed of one type of atom, and the elements are present in the periodic table. A compound is composed of two or more elements that are always combined in the same proportion. But it is important to note that these elements that form a compound are chemically bonded to one another. Here we have an example of an element. We have also an example of a compound. So when we look closely, our example of an element is graphite. Graphite is a form for carbon atoms. Next to it, we can see a compound. The example that we have is water, because at the molecular level, when we see water, it is composed of chemically bonded oxygen atoms bonded to hydrogen atoms. And every oxygen atom has two hydrogen atoms bonded to them. And that's what makes it a compound. If matter is not classified as a pure substance, then it's classified as a mixture. And a mixture is a substance that is made out of two or more different chemical substances which are not chemically bonded to one another. Mixtures can be classified further into homogeneous mixtures, which those are mixtures that have a uniform composition throughout. So you see them as one layer, or you cannot distinguish the components of that mixture. If you don't have a homogeneous mixture, the other way that a mixture can present will be as a heterogeneous mixture. And when it comes to a heterogeneous mixture, the composition of the substances varied from one to the next. And more importantly, you can actually see the different components of the mixture. So in the heterogeneous mixture, there's not a uniform composition. It looks like it has several layers. To practice the classification of substances as pure substances or as mixtures, we are going to do example 3.4 from the textbook. As you can see, we have 5 different substances and then we need to classify them. I'm going to do letter A and B. On letter A, we have a soft drink, meaning soda. Soda is an example of a mixture because it's composed of water, carbonation, caramel color in the case that it has some, it has sugar. So there's many things that came together in order to make that soft drink. On letter B, we have propane. Propane is an example of a pure substance. In parentheses, we can observe how propane has 2 letters, and those letters have subscripts that indicate numbers. In chapter 4 is where we learn elements. So I can give you just a brief preview that what the book is trying to illustrate here is that specifically the carbon atom has 3 atoms present in every single molecule of propane, and those 3 carbon atoms will be attached to 8 hydrogens. So for now, whenever we observe, and there's many examples like this, when we observe specifically that in parentheses we have symbols of elements, then that is going to illustrate a pure substance. So at this time, practice letter C, letter D, and letter E. In addition to classify matter based on its components, we can also classify matter in terms of its physical state. In table 3.1, we have a comparison of matter that can be classified as solid versus liquid versus gas. The characteristics that are distinguished between these 3 states of matter include the shape, the volume, arrangement of particles, interactions between particles, movement of particles, and you can see that in the last row, we actually have examples of each of these physical states for matter. When it comes to matter that is classified as a solid, we can see that it has a definite shape, it has a definite volume, the arrangement of the particles are very close, the interaction between those particles is very strong, and then the movement of the particles is slow. When it comes to a liquid, those substances are going to take the shape of the container. They have a definite volume. The arrangement of the particles is random, but they're close. The interaction of the particles or between the particles is strong. And then the movement of those particles is moderate. Lastly, if a particular substance is found in gas form, we can see that it takes the shape of the container, just like we saw with the liquid. But different from the liquid, a gas is going to fill the volume of the container. Those particles will be arranged randomly and they will be very far apart. The interaction between the particles is essentially none, and the movement of them is very fast. To practice to distinguish If the description of a substance is classified as a gas, a liquid, or a solid, we are going to practice by doing example 3.8 from the textbook. You can see that the instructions say that you need to indicate whether each of the following describe either a gas, a liquid, or a solid. The first description says lemonade has a definite volume, but it takes the shape of its container. When we look back at table 3.1, we can see that this substance, that is lemonade, because it takes the shape of the container and it has a definite volume, then is categorized as a liquid. Now, take a moment, read item B. It states the particles in a tank of oxygen are very far apart. Now, determine if that statement describes a gas, a liquid, or a solid.